Hi everyone, this is Purnima Mahalingam and you're watching video lecture series on protection switchgears. In last video, we are discussed about what is electromagnetic relay, the importance in relay and roles of protective relays based, what are the basic relays and protective zones and the basic connection diagram of protection zone and what is protective relay and the electromagnetic relay. In that electromagnetic relay, we have discussed about attraction, armature attraction type relay. When the coil is energized, what happens based on the reflecting or attraction force, the force gets up and it gives signal to the circuit breaker trips. So now today we are going to discuss about solenoid type relay. So solenoid type relay, what happens that when the coil gets energized, what happens? This get attracted. This magnet get attracted. Then what happens? This is connected, attached with the trip circuit, and finally this trip circuit is attached with circuit breaker. So this is what solenoid type relay. And another in construction base, we have also another type of relay, that is what balanced beam type relay. So when the iron of here we have an iron, it consists of an iron armature fastened to be balanced beam. Under normal operating condition, the current through the relay coil is such that, that the beam is held in the horizontal position by the spring. When the fault occurs, the current through the relay coil becomes greater than the pickup volume and the beam is attached to the closed the trip circuit. This causes the operating of the circuit breaker to isolate the fault current. Here we can see the balanced. Normal condition, it will be in horizontal. When the overcurrent occurs, what happens? It gets energized and it starts moving downwards. It starts moving downwards. Then it connected with the trip circuit. That is what a circuit breaker. Okay. Next one is induction type relay. What is induction relay? Then an electromagnetic induction relay operates in the principle of induction motor and are widely used for protecting relays purpose involved in AC quantities. Okay, an induction relay essentially consists of a pivoted aluminum disc. We know that this is an aluminum disc placed into alternating magnetic fields of same frequencies but displayed in time and speed. The torque is produced in the disc by the interaction of one of the magnetic field. The torque is produced by the disc when the current induced in the disc by the other. The current is induced by the disc by one another. Okay. Here we can see that. Here the flux produced in first conductor. There the flux produced in second conductor. The current passes in first conductor. The current that is I1 is directly proportional flux produced in the first conductor with respect to cos, and I2. So when force produced in first conductor is flux produced in first conductor and current flows in second conductor. Force in second conductor is current flux produced in second conductor and current produced in first conductor. The total force directly proportional to force 2 minus force 1. So second conductor force minus first conductor force. And the force is directly proportional. We can we replace that force by flux and current. And finally, flux is directly proportional. Force is directly proportional to flux produced aboard the conductor into sine theta. Okay. This is the final force equation of induction type relay. The following points may be noted for an experiment. So the maximum force will be produced when the two fluxes are at 90 out of phase. When the net force is the same, when the net force is the same when at every instance, the direction of the net force and hence the direction of the motion disk depends upon which the flux is leading. The following three type of structure commonly used to obtain the different phase difference in the fluxes, and hence the operating torque in the induction relay is divided into three types. One is shaded pole structure, next one is wattmeter or double winding structure, and induction cup structure. So these are the types of induction relay based on the phase difference in the flux and hence the operating torque. Okay. First thing is shaded pole structure. So far we have seen what type of relays. So electromagnetic attraction type relay. So we have seen attracted armature type relay and a solenoid type relay and a balanced beam type relay. And finally is induction relay. In induction relay, we have three types of in constructions wise, it is divided into three types based on the force phase difference in the flux and operating torque. Okay, in next class, we can discuss about these three types. Thank you so much for watching this video.